Alright, in this video we're going to be talking about constructing a confidence interval when our standard deviation is known. So in my problem or example, you can see it says a sample of size n equals 58 is drawn from a normal population whose standard deviation is 7.7 and the sample mean is x bar equals 45.19. The very first thing it wants us to do is construct a 90% confidence interval for our MU, or our mean, our population mean. So some of the things that you need to know about our problem are the following. The first thing we need to know is what our n value is, or our sample size. And it tells you specifically in the problem that n equals 58. It is also important to remember that it says that it is a normal population in our problem. We also need to know what our standard deviation is, our sigma, which is going to be 7.7, and then what our x bar equals, and that's going to be 45.19. One of the other things that we need to realize is what our confidence interval is going to be. So this is called our C level. And our C level, when we put it into our calculator, we can put it in one of two ways. The first way that you can put it in is exactly how you see it, as 90. The second way you can put it in is you can put it in as 0.90. I'm more inclined to put it in as the decimal only because I'm used to converting everything to decimal, so I try to stay consistent. So from here, the cool thing is your calculator does everything for you guys. So we need to know which and where we're going to construct this interval. So we're going to go to our stat menu. We're going to go over to test. Now, if you notice here, we have a couple of options. We have z-test, t-test. This one, number 3, is called our 2-sample z-test, all the way down to number 5, which is our 1-prop z-test. But if you notice, our problem doesn't ask us anything about a test. It asks us specifically for a confidence interval. So from there, what we want to do is we want to go down to number 7. We also like number 8. And we also like number A. Now, specifically for this problem, we know what our standard deviation is, or our sigma. So since we know our sigma value, we want to use our z interval. Z interval. And that is very important to remember, you guys. Z interval. All right, so we want to go and press enter. Now, with our z interval, we have two types of inputs that we can do. We can either choose to put in some data or a list of numbers, and our calculator does all the calculations over here for us and puts it in there for you. Or we can go to our stats, and that's what we have. We have our statistics. We have our sigma, we have our x bar, we have our n value, and we have our C level. And we just want to choose to put those in. So our sigma value was 7.7. Our x bar value is going to be 45.19. Our n value, or our sample size, is going to be 58. And again, our C level, you can either choose to do 90 or 0.90. Again, I'm going to choose to do 0.90 because I always do decimals when I'm dealing with percentages. So I just like to stay consistent. Now, when you calculate, you want to press enter one time. You don't want to do it twice. So this is the screen you should have now when you press that enter. So the interval that you want is going to be both numbers. We have 43.527, and then specifically whatever your problem asks you to go to decimal wise. 853. And that would be your answer for this right here. So again, your calculator kind of does everything for you guys, and that's awesome. Now for the B part though, it says if the population were not approximately normal, would the confidence interval constructed in part A be valid, and explain? So we're now assuming that it's not approximately normal. So this normal population statement is not there anymore. But the cool thing is the confidence interval constructed in A would be valid. So yes. And the reason for that is because my n value is greater than 30. My n equals 58. So because this happens, this is one of our stipulations for using z interval. Because my n is greater than 30, it is okay to assume that it is approximately normal.